Here's a short video to give you some ideas about how to solve some of these problems if you're unsure. Now let's take a look at some of the problems in step 2. Let's have a look at this one. How many hours are in 90 minutes? Right, first of all, let's relate this back to a key fact. How many minutes are there in 1 hour? Well, we know that by looking at the key facts, and we know there are 60 minutes in 1 hour. So, how could we use this fact to find out how many hours are in 90 minutes? You could use a simple subtraction. 90 subtract 60, or using a column subtraction, 90 subtract 60. We know that 60 is an hour, so if we subtract it, we know how much we've got left. If we know how much we've got left, we may be able to work out if there is another hour or not. So if we quickly work that one out, we can see there's 30 left. So at the moment we know we've used up 1 hour, but we also know that we have 30 left. Now 30 is not enough to make an hour, which is 60 minutes. So we will have to accept the fact that our answer would be 1 hour and 30 minutes. So by using a method that we know already, we've been able to work that out. Let's have a look at another one. How many minutes are in 8 hours? Well, here we've got 8 hours. Let's go back to a key fact. How many minutes are in 1 hour? Well, we know there are 60 minutes in 1 hour. How can we use that? Well, it's going to be either repeated addition. So we could have 60, add 60, add 60, add 60, add 60, add 60, which is getting to be quite a long calculation, and you have to wonder how practical that is. But when you look at that, you may also start to think that begins to look familiar. What else could I use that I have knowledge of that could help me with this? Could it be the 6 times table? Now here, looking at this great big long column addition, I think we are quite agreed you can do it, but it's a little bit impractical. You could break it down to 4 lots of 60 or 1 lot of 4 and then double it. But again, that can be quite convoluted, long-winded. But we could use our 6 times table. You see, 8 times by 60, which is how many hours there we need to times the minutes by, is very similar to, as I've highlighted to you in class before, 8 times 6. So if we find out what 8 times 6 is, which will be 48, we have to know we are now dealing with an amount that is 10 times bigger. So if it's 10 times bigger, we are going to be having a 0 at the end to indicate it is 10 times bigger. So we will have the same 4 and 8, but we would then also have a 0 on top to show that it's 480 minutes. Let's have a look at another one. I think there's one that says 35 days. How many weeks will it be? Okay, so we want to know how many sets of 7 will go into 35 days, because 7 days is 1 week. And that was one of our key facts. So we've returned to that key fact. So we want to know how many sets of 7 days there are in 35, and that will tell us how many weeks there are. So we could use the 7 times table by counting down 7, 14, 21, 28, 35. And we could count those groups up. That would certainly be one way of achieving that. Or we could use short division. How many 7s go into 3? You can't do it. Carry it over. But then we would end up using this method here and having to count on in sets of 7. And there we have the fact it is 5 weeks. So by using our times tables again, by using a skill that we've picked up in previous lessons, we're able to apply that to solve a problem involving time. The other things you may come across may involve a timeline. So if we have a look at another problem, let's say we take one from step 3, we will say how many minutes and seconds are there in 150 seconds? Okay, so first of all, we go back to a key fact. There are 60 seconds in a minute. So if we draw that first timeline and bring that over, we have now got the fact that we've got 60 seconds. We've got 1 minute. Okay, that means that there is still a bit left on there. So, do you think we could fit another 60 in? Well, let's have a go. We have another 60, and here, yep, we have 120. So, we've now had another minute. We now have a much smaller section left here, between 120 and 150. So, with that small section there, what is the difference between the two? Well, we would be able to quickly work out the difference there would be 30 seconds. This gives us a total time of 1 minute, add another minute, that gives us 2 minutes and 30 seconds. And so by using a timeline, we're able to find out how many seconds and minutes there are in a fixed amount. Sometimes that might be a bit too big, so you might have to then use other skills, such as if you wanted to find out how many minutes and seconds there are in 1,000 seconds, that would be quite a slow process because you have these numbers and jumps of 60 would prove it to be quite difficult. So let's have a look at this problem. There's 1,000 seconds. We know that 60 seconds is 1 minute. That's an awful lot to work out there, isn't it? So could we use our tables again? Well, if we use our 10 times table, or we multiply by 10 more specifically, we could then find out that 60 seconds times by 10 would give us 600. That number certainly brings us a lot closer to 1,000. Now we can see here that we've already obtained 10 minutes is worth 600 seconds. We're not quite there yet, but we've definitely got a lot closer, which means there's 400 seconds left. That number is a lot easier to find out how many 60s go into. So again, we could use our 6 times table using a method I highlighted in one of the other steps. We could count on in groups of 60. We could use a number line to count on in groups of 60 till we reached 400. So at this point, by bringing in an additional strategy, we certainly shorten that route, but then we could use other strategies to find out how many 60s then go into 400, like a timeline, like repeated addition, or such as using our tables again.